Good day, everybody. How are you all doing? Today we are going to talk about hypothesis test for the mean. That is hypothesis test for the mean with the population standard deviation known. So here I go. Mhm. So hypothesis test for population mean with standard deviation known, population standard deviation known. So in a hypothesis test, we calculate a statistic such as X bar, which is a sample mean, and compare it to the value in the null hypothesis. If the difference is large, it is less likely to due to chance, and H0 is less likely to be true. Otherwise, a small difference may be due to chance and H0 may well be true. The question is how big the difference should be before we reject H0. There are two approaches to this method. One is the critical value method, the other is the p-value method. With the calculator, we'll focus on the p-value method. So we begin with an example. A college board studies suggest that course students taking the STAT exam have a mean score of approximately 530. A teacher who runs an online coaching program thinks that the students coached by this method have a higher score than this because the teacher believes that the mean score for his students is greater than 530. The null and alternate hypotheses are null is mean equal to, always the equal to sign in null hypothesis H sub 0, and the alternate H sub 1 because he believes greater than colon mu greater than 530. Suppose now that the teacher draws a random sample of 100 students that went through this program and their mean SAT score was X bar 562. Can the teacher reject H0 and conclude that the mean of all students who go through his program will be greater than 530? The sample mean SAT score of sample of 100 students is 562 X bar. The value is higher than the null hypothesis value of 530. To determine how strong the disagreement is between the sample mean and the null hypothesis, mu equal to 530, we calculate a test statistic. The test statistic is a z-score of the sample. Remember, z-score is actually how many standard deviation you are away from the mean. So the mean, sample mean in this case is 562 and you are comparing it to the hypothesized population mean in the null hypothesis of 530. So it's 562 minus 530. That difference is 32. That has to be divided by the standard deviation of the sample means. And it is just not the population standard deviation, it is the population standard deviation divided by square root of n. You ask me why we are dividing by square root of sample size. Remember, we are dealing with the standard deviation of the sampling distribution of X bar. And the standard deviation of the sampling distribution of X bar is sigma divided by square root of n. Population standard deviation divided by square root of sample size. So it is 2.76. So what does it mean? It means the sample standard deviation of 5.62 is 2.76 times the standard deviation of the sampling means above the assumed population mean of 530. Visually, we can see from the figure that our observed value of x bar of 562 is rather far out in the tail of the distribution, far from the assumed mean of mu equal to 530 from the null hypothesis. Intuitively, it appears that the evidence against H0 is fairly strong. The critical value method is based on the idea that we should reject H0 if the value of the test statistic is unusual under the assumption that H0 is true. We choose a critical value which forms a boundary between the values that are unusual and the values that are not. Okay, in this case, the region that contains the unusual values is called the critical region. If the value of the test statistic falls in the critical region, then we reject H0. The question is, what is the area of the critical region? And here it is shown, the area of the critical region, unusual values, is equal to alpha, Greek small a. What is alpha? Alpha is actually the level of significance. What is level of significance? Is the maximum risk you are taking in rejecting H0 when it is true. That is the maximum risk you are taking in making a wrong decision. Usually alpha is fixed as at 0.05. So area of the critical region is 0.05. This will help us to determine the critical value of z on the horizontal axis, so that the area to the right of this critical value as shown by the area as shown by the arrow is alpha, which is 0.05. If that is 0.05, area alpha on the right of the critical value under the standard normal distribution, then we can go to our calculator, do second, verse, and 3. We know the area in the right tail is 0.05. So area in the left of the critical value is 1 minus 0.05, which is 0.95. Mean is 0. Standard deviation is 1. And we paste enter and enter. That critical value is 1.645. Okay. Notice that if H0 is actually true, but X bar falls in the critical region, then a type 1 error occurs. We begin a hypothesis test by setting the probability of type 1 error. This value is called the significance level and is denoted by alpha. Remember, type 1 error occurs when we reject H0, even though in reality H0 is true. The area of the critical region is equal to alpha. The choice of alpha is determined by how strong we require the evidence against H0 to be in order to reject it. The smaller the value of alpha, the stronger we require the evidence to be. One of the most common values of alpha is 0.05. When alpha is 0.05 used in a one-tail test, the critical value is 1.645. How did I do it? Second, verse 3 in the calculator, in norm area to the left of the critical value is 1 minus 0.05, which is 0.95. That is the area we will substitute or plug in the calculator. Mean is 0, standard deviation is 1, z is 1.645. Now we calculated the test statistic z 2.76, which is on the right of 1.645. Since z equal to 2.76 falls in the critical region H0, H0 is rejected at alpha equal to 0.05 level. Since H0 is rejected, conclusion is at alpha equal to 0.05, there is enough evidence to support the alternate that mu is greater than 530. The smaller the value of alpha, the stronger we require the evidence to be in order to reject the null hypothesis. In the SAT example, we chose a significance level of alpha equal to 0.05 so that the H0 is rejected if the test statistic is in the most extreme 5% of the distribution. If we had chosen alpha equal to 0.0, we would have rejected H0 only if the test statistic had fallen in the most extreme 1% of the distribution. If we reject H0 after choosing a significance level alpha, we say the result is statistically significant at the alpha level. So critical values for hypothesis test. There are three diagrams here. One is for a left tail test. When is a left tail test? Then the rejection region is in the left tail. That means alternate hypothesis is mu less than a certain value. So we calculate the test statistic. If the test statistic is less than the critical value minus Z alpha, then we reject H0. For a right tail test, that means the alternate mu is greater than a fixed value phi 0, hypothesized value in the null hypothesis. We calculate the test statistic. If the test statistic is greater than the critical value, then we reject H0. And for a two-tail test, okay, the critical values, we take the level of significance, divide it into two equal parts, area, and each tail is alpha by 2. We calculate Z. If it falls either in the left critical region or in the right critical region, we will reject H0. And this is a table, the assumptions for performing a hypothesis test about mu when sigma is known, that we have a simple random sample. Sample size n is greater than 30, or the population is approximately normal. So American Automobile Association reported that the mean price of regular gasoline in city of Los Angeles in July 2019 was $4.07. A recently taken simple random sample of 50 gas stations had an average price of 4.02. Assume that the standard deviation of prices is 0.15. An economist is interested in determining whether the mean price is less than, so alternate mu1 less than 4.07. Perform a hypothesis test at alpha equal to 0.05 level of significance. So null is mu equal to, always equal to. Our sample size is greater than 30. We know the population standard deviation is 0.15. Alternate mu is less than 0.07, 4.07. Calculate the test statistic. The test statistic is less than the critical value of minus 1.645. The test statistic is minus 2.36, which makes it fall in the critical region in the left tail. Therefore, we reject H0 and we state that at alpha equal to 0.05, there is enough evidence to suggest that the alternate hypothesis, to support the alternate hypothesis, which is mu less than 4.07. Okay. So we'll skip this. What is the p-value method? The p-value method, P stands for probability, is the probability of obtaining a test statistic, assuming H0 to be true, at least as extreme as what we have obtained. It is the probability value of obtaining a test statistic at least as extreme as the value we actually observed. The smaller the p-value, the stronger the evidence against H0. Unlike critical value method, p-value tells us exactly how unusual the test statistic. For this reason, p-values are more often used in practice, especially when technology is used to conduct a hypothesis test. Okay, so here is the same program. Same problem. Online coaching program is supposed to increase the mean SAT score to greater than 530. Null and alternate hypothesis mu equal to 530, or null alternate mu greater than. Assume that 100 students are randomly chosen to participate in the program and the mean score is 562. Population standard deviation is 116. Does this provide strong evidence against the null hypothesis? So what will we do? We can do it using the calculator. We do stat, highlight test on the top row, scroll down to z-test. Why do we select z-test? Because we know the population standard deviation is 116 and hit enter. So stat, test, z-test. Input should be on stats because we know the summary stats of the sample. Mu0, what are we comparing it? Is the value in the null hypothesis is 530. What is sigma? Population standard deviation, which is 116. Okay. What is the sample mean? Is 562 x bar. What is the sample size? 100. What is the alternate? Greater than. So bring the cursor on greater than 530 and hit enter. And go down to calculate and hit enter. So the next screen gives us the result. First, it tests the alternate hypothesis. The first line is the alternate. H1 mu greater than 530. Next line is the test statistic. Remember, it is a characteristic of the sample that we have gathered. The Z is 2.758. Then we look at the p-value, 0.002. Then we compare this p-value with the alpha value. Usually alpha is 0.05. So p is less than alpha. Decision reject H0. Okay. So that's what it is. P is very small. P is less than alpha. Reject H0. If we reject H0, then we state the conclusion at alpha equal to 0.05. There is enough evidence to support the alternate hypothesis. That what is the alternate hypothesis? Mu is greater than 530. That's what we are going to support because we have rejected the null hypothesis. So here they're showing you how to find the so this is less than, so the rejection region is in the left tail, and the critical value they have not given us. They have given us a test statistic value of minus 0.63. So what is the p-value? In this case, we will go second verse. Remember, the p-value in this case will be a value starting from the negative infinity on the extreme left, very large negative number, to the test statistic of minus 0.63. So second verse, we go to 2. Lower is indeed minus 1e99, very large negative value. Upper is the test statistic. Minus, this minus is next to enter 0.63. Okay. And mu is 0, sigma is 1. Paste enter and enter. And the p-value is 0.264. Notice this p-value is much greater than usually selected value of alpha, level of significance 0.05. P is greater than alpha, therefore decision do not reject H0, and we state at alpha equal to 0.05. There is not enough evidence to support the alternate hypothesis mu less than 5. Okay. So here is the final, here is the guidelines that we should use. Test statistics, we select an alpha, usually 0.05. It can be as low as 0.01, depending on the situation, depending on the problem. We calculate the p-value. What is the p-value? It's a probability value of obtaining a test statistic at least as extreme as what we have calculated. If the p-value is less than alpha, reject H0. If p-value greater than alpha, do not reject H0. Okay. So here they're showing us an example of H0 is rejected 0.1. If P is 0.12, do not reject H0. If P is 0.07, reject H0 compared to alpha 0.1. Okay, and determine whether the result is statistically. So when P is 0.05 and alpha is 0.1, P is 0.05, decision reject H0. So to alpha equal to 0.05, there is enough evidence to support the alternate. However, if P is 0.2, P is greater than alpha, do not reject H0. Okay. So p-values, this is how the calculator. So p-value for a left tail test is the area to the left of the test statistic. And for a right tail test, p-value is the area under the standard normal curve to the right of the test statistic. And for a two-tail test, we take area in one tail and multiply it by 2. So the mean height of adult men in US is 69.7 inches with a standard deviation of 3 inches. A sociologist believes that taller men may be more likely to be promoted. So the mean height mu of male executives may be greater than the mean height of the entire male population. Simple random sample of 100 male executives has a mean height of 69.9 inches. Assume the standard deviation of male executive height sigma is 3. Can we conclude that the male executives are taller on the average than the general male population at alpha equal to 0.05? We first check out the assumption. Okay, so we have a simple random sample. Sample size n is 100, greater than 30. Assumptions are satisfied. Null hypothesis mu is 69.7. Alternate mu greater than. So this is a right tail test. So we go to stat, highlight test on the top row, then select z-test. Again, we select z-test because we know the population standard deviation. Input flashing on stats. Mu 0 is what value we are comparing to, is 69.7. Sigma population standard deviation is 3. X bar is 69.9. N sample size 100. Alternate hypothesis greater than mu zero. So bring it on greater than mu zero, the cursor, and hit enter. It should be flashing on greater than mu zero. Remember that line indicates the alternate hypothesis. We go down to calculate and hit enter. We look for the test statistic, which is 1.67. P-value is 0.047, which is less than alpha. Decision reject H0. And we conclude that at alpha equal to 0.05, there is enough evidence to support the alternate that mu is greater than 69.7. Okay. And we will let you do this. Okay. Social scientist suspects that mean number of years of education of mu for adults in a certain city is greater than 12, so alternate is greater than 12. She'll test the null hypothesis mu equal to 12 against the alternate mu greater than 12. Random sample of 100 adults, sample mean is 12.98. The standard deviation for the number of years of education, sigma, is 3. Find and interpret p-values. So first we are dealing with a simple random sample. Sample size is 100, greater than 30. So the conditions are satisfied. Then we will do stat, test, and again select z-test because we know the population standard deviation. Input should be flashing on stats. Mu 0 is the value in the null hypothesis, which is 12. Sigma population standard deviation is 3. X bar sample mean is 12.98. Okay. And N sample size is 100. And alternate is greater than mu 0. We go down to calculate and hit enter. P-value is not 5.44. There's a E minus 4 at the end, which means P-value is actually 0.30 and 5. E minus 4 means the first digit or first number 5 is at the fourth place after the decimal. The first three are 0, 0.0005. So compare that with alpha value of 0.01, P is less than alpha. Decision reject the null hypothesis. Conclusion at alpha equal to 0.01. There is enough evidence to support the alternate that mu greater than 12. Okay. So that's it for today. If you have any question, comment, write me a note. If you like this video, please share with your friends. If you like this video, please give me thumbs up. I really appreciate that. I will that will motivate me to do more videos for you. So please give me a thumbs up. And if you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. Also, please do not forget to click on the red bell button because that will inform you every time I upload a new video. Thanks for watching. Thanks for taking the time to watch my video, and please do not forget to watch me tomorrow when I'll come up with a new video. Thanks. Take care. Have a nice day.